Hey guys, Sean Alexander here with day 5 of the Relativity lectures. I really appreciate you guys all sticking with this. As always, I thrive off of your comments. So we're gonna try something new. I'd love if you comment this video. It would help us out a lot if you put the comments in on the video on the YouTube page and gave it a little thumbs up. Apparently that's helpful. So if you guys could do that, I'd really appreciate it. Okay, let's do it. Today we're going to get into the nitty-gritty. So what have we learned so far? I asked you, what is a second? Got some great responses. Then I asked, how do we measure a second? And then we got into the idea of simultaneity and how we measure time intervals. So again, it's very difficult to say what a second is without looping the definition of time back in. And so what we decided on is, in order to define a time number, we need to all agree upon a motion. And a simple example will be the wall clock rotating at a certain rate. So we're going to compare our motions, walking around the room, showing up to class on time, to this agreed upon spinning thing on the wall that's rotating at an agreed upon rate. And we say that if we showed up to class at 8 a.m., we mean to say that our location in space, that is the classroom, coincides with the rotating thing on the wall hitting the 8 a.m. position, okay? And we call that a simultaneous event. Two motions are simultaneous. Okay, so now we're going to actually get into the real Einstein stuff. We're going to go over the two postulates of the special theory of relativity. What is a postulate? A postulate is something that's assumed to be true without further backup. So postulate is basically like, it's as basic as you can get. There's no proving it. It's like blue is blue. You know, what color is the color blue? It's basically as simple as you can get. So we'll start with postulate number 1, and that is the speed of light is the same or is constant for all observers. Does that sound normal? In fact, it's crazy. And we'll get into why it's crazy in just a second. First of all, for those of you who don't know, light travels at the speed of light. It's very fast, 186,000 miles per second. So just to give you an idea of how fast that is, something traveling at the speed of light could circumnavigate the Earth 7.5 times in 1 second. So it's very fast. And what the first postulate is claiming is that no matter how you're moving, and if you measure the speed of light, you're going to get the speed of light, or 186,000 miles per second, no matter what, no matter how you're moving relative to the light. So let me tell you why that's nuts. Forget light for a second. Let's say that you are on one of those people walkers at the airport. You know what I'm talking about? I know you do. Not that you've been to an airport lately, but you know, you go on these people walkers and it moves you this way. And just for argument's sake, let's say the people walker moves you at 1 meter per second. And that's if you're just standing still. To an observer on the ground who's not on the people walker, well, he would see you cruising by at 1 meter per second. Okay, so let me ask you this. If our guy on the people walker now starts walking at 2 meters per second relative to the people walker, and this guy down here on the sidelines has a radar gun and radars your speed, what speed do you think that he would radar? So again, the guy in the people walker is going at his normal 2 meters per second, and the people walker is moving him at 1 meter per second. So you would think, obviously, that the guy on the ground would observe you to be moving at 3 meters per second, or the sum of the two speeds. Okay, that's totally true and totally logical. So let me tell you why that makes the above statement, the speed of light is constant for all observers, totally bananas. Because if we just take the same analogy, and I say that the dude on the people walker now has a flashlight and turns on the flashlight, and we have a light beam going this way at the speed of light. By the way, we use the letter C always in math to represent the speed of light. And the people walker is still moving at 1 meter per second. How fast do you think the guy on the sidelines would radar gun the light beam to be going? So if he could somehow magically, measure the speed of the light beam relative to the embankment, What speed do you think his radar gun would say? Well, according to our theory from before, the rule is you just add the velocities, right? You add the velocity of the light beam plus the velocity of the people walker. So you would think that the radar gun would measure the speed v to be c, the speed of light, plus 1 meter per second, which would be 1 meter per second faster than the speed of light. However, that contradicts our first postulate, which says the speed of light is constant for all observers, meaning you're going to measure the speed of light no matter what. So one of the reasons that's crazy is we're basically saying that even though the dude's on the people walker, the guy with the radar gun on the embankment is going to measure that light beam to be traveling at the speed of light. Okay, that's weird. Now we're going to do an exercise where we go into what we call the reference frame of the guy on the people walker. Now, as far as he's concerned, if he's not moving this time, he's just standing still, and he turns on his flashlight. And let's say this guy's got the radar gun now, okay? The guy on the people walker has the radar gun. And he turns on his flashlight, and he can somehow measure the speed of his light beam relative to himself. What's he going to get? Well, according to postulate 1, he's going to get c. So in other words, the guy on the people walker, who's not walking relative to it, he's just cruising along, turns on his flashlight and measures its speed. He gets c, the speed of light, 186,000 miles per second. But the guy on the ground, watching the guy on the people walker go at 1 meter per second, turns on his flashlight. Well, he gets c too. So that's crazy, right? So postulate 1 is actually weird, and I'm not going to get into why that is right now. In fact, I'm not sure if anyone can tell you for sure why it is, but we'll get into that. But that's postulate number 1 of the speed of light. Basically, anyone who measures a light beam is going to get c no matter how they're moving relative to the light beam. 2, this is the second postulate of special theory of relativity. The laws of physics are the same in all non-accelerating reference frames. I'm going to explain this. The laws of physics are the same in all non-accelerating reference frames. What do I mean by that? Basically, if you're going at a constant speed, meaning you're not speeding up, slowing down, or turning, any experiment you do will be the same as if it was on the ground. So let me show you what I mean by that. What this 2 claims, which is also kind of crazy, let's say you were in a car going at a constant speed, let's say 5 meters per second to the right here. And let's say this car had no windows and just the best suspension of all time. Okay? And you were inside this car. So you can't see outside. There's no signals coming in or out of the car. You're in this windowless car, and it has perfect suspension, so you don't feel the vibrations. And from someone outside, they can tell it's going at 5 meters per second. What I want to ask you, what I'm going to leave you with today, and this is for your comments, is there any way the guy in the car could figure out that he was moving? And you can assume that he has access to all the best scientific equipment in the world inside the car. There's no ins and outs, meaning there's no signals going in or out of the car. But he had the best scientific equipment in the world. Would he be able to figure out that the car is moving? Is there any way he could figure out that the car is moving? Okay, so just so you know, this isn't totally round. That's what I'm going to leave you with today. So please think about it and put your comments in the comments section of the video. And then we're going to see how these 2 rules, postulates from Einstein. 1, the speed of light is constant or same for all observers, and the laws of physics are the same in all non-accelerating reference frames, is a huge paradox. They contradict each other. We're going to see how next time. But for now, just to set it up for next time, what I want you guys to answer, please, in the comment section is, for the guy in the car who can't see in or out and is not vibrating, is there anything he could do? Is there any experiment he could perform inside the car to determine whether or not he's moving? Okay, so I'm gonna leave you with that. If you like the video, please give it a thumbs up, and I will see you guys next time, and we'll really dive into these two postulates and see how they relate to each other. Thanks, guys. Have a good one. Bye.